Let's talk about the difference between accuracy and precision. Accuracy means how close our number is to the actual number, right? How close our value or our measurement is to the real true measurement or the real true value of whatever number we've got, whatever we're measuring, whatever we're calculating. Precision means that if we do that same thing over and over and over again, that we will get the same answer over and over and over again. You can be precise without being accurate. Okay? Here, if you look down here, we've got a dartboard, and here we've got a very accurate and very precise result. All of our arrows are in the same place, and they're very close to each other. So they're precise and they're accurate. Okay? We could have precise shooting that's not very accurate. Here again, all the arrows are in the same place, so my precision is pretty good, but I have pretty terrible accuracy. I'm far, far, far from that target, that bullseye. Okay? I can have things that are not very accurate or precise, right? If I shoot all everywhere. Here I've got very limited accuracy, not very much accuracy, and not very much precision either. So this method that I was using didn't give me great results. What you want is something like the first one, where every time you're getting an accurate result. That's the kind of tool and the kind of method we want to use. Something that's going to give us very close to the accepted value, and it's going to do it every single time. So let's look at what that means for numbers and tools, since that's what we will mostly be using. Okay, remember that precision means we get the same answer every time. Or the same result every time. And accuracy, for accurate, that means that we get a result that is very close to the actual value. Okay? When we're looking at tools, we want one with more markings, because more markings means that it's more precise. Here we've got 3 meter sticks, one that has a marking every meter, one that has a marking every 10 meters, and one that has a marking this is every 10th of a meter, and this is one every 10 meters. Obviously these are not to scale, but nonetheless we're going to use them. Okay, the reason that more markings gives me a more precise measurement is because if I'm measuring something with this one, then remember that one of our digits is going to be an estimated digit, right? So here I can read off 3, but then after that I have to estimate. I'm going to estimate about 3.5 meters. If you were reading that, you might estimate a little bit differently. You might estimate 3.6 meters. So it's not always going to give us the exact same answer. If I'm using this one on the other hand, right, then I can read it to a much greater level of certainty. I can read 4 meters, and I can read that it's between 0.5 and 0.6, so 0.5, and then I can estimate that it's a little bit closer to the 0.6 marking than to the 0.5 marking, so I'm going to read 4.5 and maybe 7/100ths of a meter, right? So my estimated digit now is in a smaller place value, so that makes it more precise. Because everybody who reads this is going to read 4.5. This estimated digit might be a little different. Up here, everyone who reads it can read that it's at least 3 meters, but this 10th place digit is going to change depending on who's reading it. Down here we've got an even less precise tool, because I'm going to have to estimate even from the ones place. I know it's more than 0 and less than 10, but that's as close as I can get. I'm going to estimate that this is maybe 7 meters, but this digit itself is an estimate. which means that if you're looking at this, you might think it's 8 meters, closer to 8 meters, or someone else might think it's closer to 6 meters. Not everyone who reads this is going to get the same answer. It works the same with graduated cylinders. Okay, here we've got a graduated cylinder that has markings every 20 milliliters. Here we've got a graduated cylinder that has markings every 10. And here we've got a graduated cylinder that has markings every 2. So here I can tell that it's more than 20 and less than 40. I'm going to estimate that it's maybe 30 milliliters. Here I can do even better. This is an estimate here, right? I don't know that for sure. I'm estimating, and you might estimate a little bit different than me. But here I can do even better. I know that here it's between 20 and 30, right? So I think it's a little bit more than 25. So I'm going to say it's like 27 milliliters. Again, here this digit, you might say 28 or 26. Somebody might even say 25. So this ones digit might change from person to person. But here, I'm even closer. I have every 2 milliliters there's a marking. So I know that this is more than 20, 22, 24. It's about 26. And it looks to me like it's right on that 26. So I can say 26.0 milliliters. So now I'm even more precise because I have even less uncertainty. I'm only estimating in the tenths of a milliliter now. Right? So I'm much more accurate than I was when I was estimating entire milliliters or tens of milliliters. What if you don't have the tool? Someone else has already done the measuring for you. Well, then the number with the whose last significant digit is in the smallest place value is the one we're going to call the most precise. Because we know it's that last significant digit that's the one that we estimated. So if I have something like 3, 3.5, and 3.56, it is this, oops, I forgot to put my unit. It is this last number that is the most precise. Because I know that this was a red measurement, this was a red measurement, this is my estimated digit, right, in the hundredths column. But here my estimated digit, the one I had to estimate, is in the hundredths, in the tenths, sorry, and this one is in the ones. Those are both greater than the hundredths here where my 6 is. Okay? If I have something like 500, 510, 512, 512.4, right? This first number here is my estimated digits in the hundreds column. That's not very precise. Here is my tens, that's an estimated digit. Here my ones is the estimated digit, and here it's the tenths. So again, this is going to be the most precise number. What if I have 12.8, 12, 12.08, and 12.080? Which of those is the most precise? Well, we need to know which one has the greatest number of sig figs. This one has 1, 2, 3, and the last one is in the tens column. The tenths column, right? We're at the tenths, 0.1 column. Here it's got only 2, and the last one is in the ones column. Here we've got 1, 2, and embedded 0. That's 3, 4. And the last one is in the hundredths column. Here we've got 1, 2, embedded makes 3, 4, trailing with the decimal makes 5. So this last one is in the thousandths column. So that makes this one my most precise number. Okay? So let's review what we've learned. Precision means we get the same answer every single time. Accuracy means that our results are very close to each other. When we're looking at tools, we want one that has the most markings. That's the most precise answer. It's the one that's going to most likely to give us the same answer every single time. And when we're looking at just numbers, we want the number that has whose last significant digit, whose smallest significant digit is in the smallest place value. That's the number that has the most precision to it. Okay? Now, whether or not these numbers are accurate would depend on how accurate our tools were, right? So is that, when we're looking at the tools, is this marking of a 1, is that actually a meter? And is this actually 2 meters? If the markings are wrong, then we're not going to get really great accuracy, but we will get good precision if we have more markings on it. Okay?